Okay, this is anomalous behavior of nitrogen. Mm, Anomalous behavior of nitrogen is due to small size, high electronegativity, non-availability of d orbitals in valence shell, and ease of multiple bond formation. So the option all are correct for anomalous behavior. Apart from these, I would like to share some anomalous behaviors with you, which can also come as a questions. Anomalous behavior of nitrogen. One is, apart from these properties, it has high ionization energy also. Ionization energy as one point. Then nitrogen as a element exists as diatomic, whereas phosphorus exists as P4, arsenic exists as As4, and antimony also exists as Sb4. Third, nitrogen shows less catenating property. It is showing less catenating property. Okay, that's it. Then less catenating property than phosphorus, the next element in the vertical group. Okay, then next catenating properties. Normally nitrogen is inert gas. Okay, and whereas other family members are reactive. Then next important point is nitrogen has absence of d orbitals. In the sense vacant 3d orbitals. So you can say that it's vacant d orbital rather than 3d. So because of this, nitrogen covalency is limited only a maximum of 4, whereas the other family members have covalency up to 6. Example, nitrogen maximum covalency is 4, that can be seen only in NH4 plus NR4 plus, where R is a alkyl group. Organic compounds also are there where nitrogen is limiting its covalency up to 4. Next, due to the absence of d orbitals, nitrogen cannot form d pi p pi bonding. Okay, whereas other elements can form d pi p pi bonding. Next, due to the small size and high electronegativity, due to the small size and high electronegativity, nitrogen can form N3 minus ion, as well as N3 single minus ion is also possible. So this is called azide ion. This is nitride. Whereas phosphorus, whereas other elements, phosphorus, antimony, bismuth, cannot form trinegative anions. Cannot form trinegative anions. Okay, then the next anomalous property, nitrogen can form hydride, which is highly stable, due to the presence of intermolecular hydrogen bonding. Okay, this kind of hydrogen bonding is absent in the other members of the group. It's absent in other members. Okay, that is the reason ammonia has a very high boiling point. Because of intermolecular hydrogen bonding. Fine. Next, nitrogen can form totally 5 oxides. 5 oxide, N2O, NO, NO2, N2O3, N2O4, as well as N2O5. Okay, this NO2 and N2O4, they are interconvertible because NO2 is having a paramagnetic character. Okay, similarly, NO, nitric oxide also is paramagnetic. So these are the two paramagnetic species. And one more thing about NO is, due to the paramagnetic character, it can also dimerize and form N2O2. All these oxides are possible in nitrogen, but other members cannot. Then, next anomalous character is nitrogen is the only element which can form compounds with oxidation states -3, -2, -1, 0, +1, +2, +3, +4, +5. Almost 1, 2, 3, 4, 5, 6, 7, 8, 9. It can form 9 oxidation states, whereas other members cannot. Okay, last anomalous property, nitrogen can form pentahalides. Nitrogen can form pentahalides. To some extent, phosphorus also forms pentahalides, whereas other elements cannot. Okay, yeah. So in this 11 anomalous character also, this is an extra point what I'm giving. You can take a notes and keep it with you. Revise inorganic chemistry. studying again and again, and practicing in organic chemistry only will lead to your success in the exam. Very, 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 very important. Okay, yeah, welcome to inorganic chemistry. Have a great day.